And don't the stars look different down there?
Well, we have the Southern Cross on our flag, which you can't see from here. And also, when you look at the night sky, you can see the stars going clockwise. Well, here they go anti-clockwise or counterclockwise, as you say.
I remember my first trip to Australia, I was having the hardest time figuring out how the heavens worked until I turned around with my back to the north and I bent over backwards so everything was going in the right direction. It's like, okay, then I knew where I was in the world. Which is funny because that would never be a phenomenon if the Earth actually was flat.
It'd be totally different. You wouldn't see the things that we do in Australia. And in fact, when we look south anywhere in the southern hemisphere, we see the south celestial pole. Or if you've got good binoculars, it's...
Okay, well, what is a south celestial pole for the listeners?
Okay, the south celestial pole is the center of rotation that you will see the stars rotating around if you have slow motion photography.
So for northern hemisphere listeners, when we look to the North Pole, if you could stare at it or take a long exposure photograph, you see a bunch of circles of the stars orbiting the North Star.
And they go counterclockwise.
And if you look south from the southern hemisphere, you see the same thing.
You see the same thing in the opposite direction, rotating around a star called Sigma Octantis, but it's a very faint star, so you need binoculars. The thing is, no matter where you are, see, on a flat disk, people 6 time zones apart should be 90 degrees apart, and yet they look south, and they all see the south celestial pole. That's not possible on a flat Earth, because you'd be seeing different stars if you were really 90 degrees apart, as you would be 6 time zones apart.
But you and I both know from much experience, because we've written a lot on this subject, more than I ever should have written, that there's always an excuse.
I haven't heard an excuse for some of these, because I think a lot of these guys have never been to the southern hemisphere.
True, but they say, oh, that's not true, or there's atmospheric lensing, or they invent some sort of a magic thing that explains a phenomenon that doesn't need any magic at all.
It doesn't need any magic if we realize that we're on a globe and not on a disk.
With the star trails, that's what this video is all about. Let's get right to it. Now, taking a look at the flat Earth model here, and again, I said it many times, where we don't know the full dimensions of the flat Earth. This is basically a representation, and the point is again, when it comes to star trails, I have to set the foundation so people understand exactly what they'll be looking at with, again, the sun and the moon that circle above like a clock. When you look at the moon from the inner circle, like I said earlier, the inner circle, not the northern hemisphere, say, for example, from China or Russia, when you look at the moon, you're going to see its face on one side here. You see here that how the northern hemisphere moon looks like. Of course, we only see one face of the moon, and here's the southern. So it's very, again, easy to understand why we see the moon from different aspects of the inner circle and the outer circle, and why they appear as they do. And of course, we see the sun and the moon in the sky often as the sun circles above. Say, for example, you're in California and say it's about 2 o'clock, 3 o'clock. On many occasions, you'll see the sun and the moon in the sky at the same time, with obviously both of them above the horizon at the same time. What is the other side of the so-called ball Earth getting as far as moonlight or sunlight during these periods of time? Can happen. Now, regarding star trails, once again, so when you're looking from, again, the inner circle, you're looking as the sun and the moon circle above the flat Earth. You're looking towards the south. Now, when you're on the so-called southern hemisphere, which is the outer circle or the outer rim, you're looking from this perspective. Let's actually use Australia again with this example. So once again, you're looking at this face. You're looking at this face of the moon. And of course, as it circles clockwise, it always circles, of course, clockwise. You're going to see it from the perspective from Australia going left. So it's making the circle here. And again, the inner circle, you're seeing it go to the right. That's simple, just like a racetrack. Now let's take a look at some actual time-lapse footage. So you'll see how it all makes sense. And this will completely debunk the so-called southern pole. Now let's take a look at this footage of time-lapse star trails from Coonabarra Brand, Australia. And this is looking at the west to the setting sky. You see the star trails going clockwise. Let's continue to take a look here as we go through the footage. And it's going to be very clear. It's all about angle. It's all about perspective. Where you're standing, where you're looking. the direction. Now this is looking towards the east. Again, same. It's going clockwise. Okay. Now we're going to get a different aspect. Again, a different perspective, a different angle. And you'll see these star trails move in a completely different direction from the southern hemisphere. This is looking north at the seasonal constellations. Now you see the star trail going counterclockwise from Australia. So this is not something I'm making up, it's not something I'm imagining. The person basically that did the time lapse with this video, that so-called southern hemisphere time lapse footage of star trails proves the globe. Absolutely not. As we all seen, obviously star trails in the so-called southern hemisphere once again travel both clockwise and counterclockwise. So it has absolutely nothing to do with supposedly living on a bogus globe. Now here's a major issue, again with the outer rim or outer circle. As you can see here with this flat earth model, this flat earth map. Basically, again, this is just a general representation. But the point being is when it comes to the inner circle within the so-called equator, we can all see Polaris, a North Star, stationary above the North Pole from every aspect of the inner circle. Now, here's the major issue, and it is the Southern Cross. It cannot be viewed simultaneously from the outer circle. Can't happen. Doesn't happen because we don't live in a ball. Now with sunsets, looking from the outer circle to the north, and from the north, from the inner circle looking south. Again, from this aspect, looking south from the northern circle, you're going to see the sun go towards the right, and of course, from Australia, go towards the left. Let's get right to it.
What I learned later is when you make a website for your videos or for your work or whatever.
To it. Now with this footage of the sun setting in Australia, and again, the sun is obviously moving towards the left. It's making that tight circle within. And take a look at this footage as well from Australia. Again, moving towards the left. And take a close look as you see a star. It all coincides. It all makes sense. As you can see right here, the star moving left as the sun sets. Which actually, it's not setting per se. It's circling above. And I'll get into that in a little bit, how that works on the flat earth model. Again, there you see it going towards the left. And this is some footage right here of the sun setting over Lake Michigan during winter, over a frozen Lake Michigan. And you can see the wider circle it makes because, again, it's in the inner circle. So you can definitely see that sun, and you can see it's a local sun with the illumination of the clouds. If the sun was 93 million miles away, the whole sky should be illuminated. All these clouds should be lit up. It's not. It's again, a smaller local sun. Continue on a little bit more, and I'll explain. Well, some might believe, oh, that sun is going around the ball Earth. Absolutely not. It's just like this row of telephone poles where the nearest pole looks taller than the rest. But as we all know, they're all the same height. Okay, they're all the same height. It's just how the human eye works. Just like when the sun is so-called setting, it's not actually setting. It's basically remaining the same height in the sky. But again, due to perspective, as it goes off in the distance, just like these telephone poles, it only appears that the sun gets lower and lower and lower as it goes beneath. Just like the telephone poles down the row, eventually you cannot see the furthest one. It's not because of curvature. It's, again, due to perspective.